So you're going to see a bunch of different formats for solving radical functions. The biggest part of what you're doing with this is we're trying to get x, either one solution, there might be two solutions. Okay, so factoring kind of comes back to haunt you. Sorry, it's coming. All right. When we're looking at any kind of problem where there is a single square root, so I always just call these single root problems. All right, your goal is to get the root completely by itself before you square both sides. So, what do I need to end up moving on that first problem? Yeah, the negative 7. We'll divide both sides by negative 7. At what, 6? So once you get the square root completely on its own, then you'll go through and square both sides. Alright, so I'm left with 36 equals x divided by 7. Because when I square a square root, it just disappears, right? It's my inverse function. Now I gotta multiply 36 times 7. Anybody got a calculator with me? Because I don't know about y'all, but I can't do 36 times 7 in my head. Oh, sweet. You can. Ta-da! That's it. What do we think about that so far? You okay? Alright. The second example, any ideas what we're going to start with? Do I have square roots on their own on both sides? So I'm just going to start immediately with squaring them. So if I had to title this, it would be double root. Alright, then I'm just going to 3n equals 1 minus n. Is that just a regular solve for n type problem? Yep. So, I'm going to do this. I get negative 2 equals 2n. Divide both sides by 2, and I get n equals negative 1. Do we want to add on to the notes now and just be done with notes for the next couple days? Might as well. Okay. So for this one, if I had to name it, it would be single root with a variable on the other side, because there is a single root and I've got other stuff on the other side. It's not just a number, right? So when you go to square both sides on this one, you end up with an n squared, right? So I've got 80 minus 2n equals n squared. So all of that crap from quadratics in Unit 2 from the beginning of the year is coming back, where we got a factor. Alright, when you go to do this, keep your n squared positive. I know it's tempting to just move the n squared to the other side, but you want to make sure that stays positive, so I just move the other two over. So I'm left with n squared plus 2n minus 8. Do we want to refresh the factoring? Yeah. So once you get to this point, you're normally doing whatever is in front of n squared times your c value, which is just 1. And then I'm looking at all of my factors of 80. So 1 and 80 I know is not going to help. 2 and 40. 3 I don't believe goes into 80. 4 and 20. 5 and I think it's 16. 6 go into 80? No. 8 should. So that's 8 and 10. And remember, I'm always looking for when I'm going to get 2. Alright, I'm looking for that middle term. So for me to get a positive 2, it's going to be 10 minus 8. So I've got n squared plus 10n minus 8n minus 80 colon n here, colon negative 8 here. So my final answer is n minus 8. Now here's the deal. I have two possible answers on it, right? I have positive 8 and negative 10. So n equals positive 8 and negative 10. The problem is, can I plug both of those in and get them to work? Which one doesn't work? Am I ever going to square root something and get a negative out the other side? No. So this one right here is called extraneous. All right? Extraneous is the fancy mathematical term of just being extra. All right, do you guys want to flip through the homework for the next couple days and look and see if there's anything that sticks out to you like, I don't want that? So start by looking at 7.6, probably day 2 is where I think things are going to start getting a little picky. Alright, do you guys see any that look like you definitely want to go over them? Number 2? Yep. Alright, so 7.6, we've got good problem choice. Yeah. Alright, now, these look absolutely hideous, and that's because they kind of are. We are still going to start off by squaring both sides. We want both of the radicals on the same side, but we're still going to do that. So I'm going to take this entire thing and square it, and then I'm going to take that and square it. So remember all that Punnett square stuff? I would use your Punnett square. So you've got square root of 3 minus k minus negative 2 minus 3k. I definitely negative 2 minus 3. Anybody freaking out yet? A little bit. So, there are going to be two things that end up completely breaking out of their square roots. Alright? It's going to be this upper column right here. What are you doing? Alright, so this spot and this spot will both break out of their square roots. Yes? Alright, this one ends up being just 3 minus k. And then this one over here is negative 2 minus 3k. So I got some progress. I got at least 2 of them out. Now, when you go to do these other ones, remember, under square roots, you can multiply everything that's under them and throw them under one giant square root. Does that make sense? So, I've got a negative, giant square root, 3 minus k, times negative 2 minus 3k. Shouldn't I get the same thing in the upper right-hand corner? Alright, so when I'm looking at this, these two right here combined give me a negative 2 times that horrible purple square root. Then after it, I've got plus 3 minus k, minus 2 minus 3k, and then this is just going to equal positive 1. Because we were lucky, that right-hand side was nice, right? I can deal with it. So we're going to start off by ignoring the purple just a little bit, and we're going to combine everything in blue and then move it over to the other side. So on that blue stuff, I've got 3 minus 2, that gives me 1, and then minus 4k. And this will still equal 1, right? Can I move everything in blue over to that right-hand side? So subtract here. Oop, that's nice. Those cancel. And then add 4k. Icky square root equals 4k. Is that square root completely alone yet? What do I need to do? Divide by a negative 2. Slightly less hideous. How many of you are like, still, it's gross. I hate it. I don't want to do it. So it looks a little worse than you want it to, but it still doesn't mean you can't solve it. So I am left with 3 minus k, negative 2 minus 3k, equals a positive 4k squared. Alright? Can I do all of the crap I need to on the left hand? Boil it all out, combine like terms, get the solution. These are tedious more than anything else. So if you know that you hate these, do like one of them at a time, and then do other easier problems to give yourself a little brain break, and then go back and do another one. But don't sit and try to do all of these at once, because let's be honest, how many of you have run out of paper on this one problem, right? So, 3 minus k, negative 2 minus 3k, Does anyone want a giant sticky note to extend their work for this problem? We're good. Alright. Left-hand side of my equation is now 3k squared minus 7k minus 6 equals 4k squared. Take everything from the left and move it. I know you're like, I don't want to. Like, why would I do that? I could just move the single 4k squared and call it a day. But then you're still dealing with a negative. So I guess you could and just divide everything. It's kind of whatever floats your boat. See how everything now is negative? I can still divide by a negative 1, because what's 0 divided by anything? 0. So, k squared plus 7k plus 6 still equals 0. Can I factor that? 6 and 1? So my solutions are going to be k equals negative 6 and a negative 1. So are any of those going to be extraneous? Maybe, no. You want to check? So you do have to identify which one's extraneous. And don't worry, if I'm going to give you one of these on the test, there would only be one. I'm not that vicious. Alright, so your original formula. We'll start by plugging in a negative 1 first. 3 plus 1 minus negative 2 plus 3. Does that work? Doesn't equal a negative 1. So, negative 1 so far is extraneous. Plug in my negative 6. So 3 minus 4, does that give me negative 1? Yes. How many of you were not expecting the negative 6 to be the actual solution?